Good. Yeah. So I think I will be able to see the Teams window through the whole presentation. So if you have any questions as we go along, please don't hesitate to raise your hand or something to ask them. I'm a big favor of two-way communication. So yeah, feel free. So let me begin with just a quick ask, by the way. Is everyone from Norway, or do we have anyone from different locations as well today? Because that will affect which demos I will be running. So could I just get something in the chat if you're not in Norway? You don't have to be from Norway. Just be outside of Norway today. See, someone is typing, so that's good. And while typing is happening, I'll pull up the presentation. So let me find the share button and the percent in Teams. Percent. Good. So you should be able to see a screen saying Azure Front Door, right? Good. So Azure Front Door is a well-known service, but also a service that we don't see too often being deployed, which is a bit strange because it's actually one of the most complete and powerful load balancers in Microsoft Azure as of today. So I'll dive in a bit on what it is, how it can be configured, trying to highlight some of the really valuable capabilities which is available in the product, and I also try to have as much as live demo exercises as possible. But just to set the context a bit, I want to say something about why this is important, because Azure Front Door is not only a load balancer on the lower level, like we are probably familiar with load balancing servers and stuff. This is a load balancer that is also operating on level 7. So that means that it will be able to load balance on the HTTPS request or the domain name, and also the paths of that domain name. So you can configure it to load balance parts of an URL in addition, which is quite valuable. And another reason for why Front Door is such an important product to use when you do global applications is because it's able to also prioritize which server backend you're hitting depending on where you're coming from. And it will also route the traffic through Microsoft Backbone Network. I'm going to dive a bit more into the details of that one afterwards. So in the high-level thing, when a user uses an application and tries to access an application, the user will do an action. The request will be sent to the server, for example, a website. That website will process the request and give a response to the user, and the user will finally get a result. So this is kind of the basics when it comes to the actions from a user does something until the server receives the request and responds and gives the user a valuable input. So when we are doing global applications, this can be a bit complicated because if we look at what happens during a request like this, you can see that the initial request is that the phone or device which is requesting the application will first do a TCP connect. So it's communication going from the device to the server and back saying, I want to talk, right? And with HTTPS connections, there is additional jumps back and forth. You have to do an SSL connect and say, hello, this is me. This is my certificate. Will you trust me? And back and forth, yes. And finally, when that happens, the actual latency of the app will also inflect a lot on actually sending data back and forth. So the time until the first byte is sent to the device is actually quite long. All these requests have latency in milliseconds. So in some cases, it can even take seconds, maybe 2-3 seconds until the first set of data is sent to the device, which can result that the users experience the application as slow or not responsive, which also will, in very many cases, have the effect that the user will stop using the app and do something else instead, because nobody likes to wait for such stuff, right? So when that happens, the first byte is sent, then the device will continue to communicate back and forth, depending on the size of the packages, and eventually the end user will get its final result and the actual thing that gives the value in that application. So when you then have front door, so this drawing is also showing how you can distribute the traffic over different servers, right? So if one of them goes down, the router will send it to another server, which helps on the availability, but not necessarily on the latency. So to demonstrate this, we have a user trying to access an application from Europe. You can see the communication path is quite short, right? You will get a response within a second or something. If this happens from US, for example, trying to access an application, this would add latency of at least 100 milliseconds on every communication package going back and forth, which will then result in an experience that this application is really, really slow and not giving the value that the user is expecting. So by sending this on the front door, you will then be able to use Microsoft Backbone networks instead of public internet, which will reduce the number of seconds it takes. In addition to, it will also reduce the number of hops the application needs to traverse. Because Azure Front Door is something which are called a globally distributed application load balancer. So there's a couple of alternatives out there, but in Azure, it's the Azure Front Door, which is the solution for this. So Azure Front Door has edge location or POPs in a lot of different cities across the world. So whenever you try to access the application, it will take the shortest route to the Microsoft POP location and then go over Microsoft backend to the final destination. It also has a firewall enabled, so you can actually have quite good firewall capabilities on the workload as well. So by enabling front door, you can see that from the previous image, we had a lot of long paths going back and forth for the connections, right? With front door, this communication will be reduced to the shortest route between the user and the first front door POP location, and then the backend will also go over the Microsoft backend network to communicate with the application. So the app latency is the only thing that actually makes the application go slow for the user. Sorry, my voice is breaking up a bit, but I'm going to try to survive. So this gives us the Azure Front Door will then give us a service that are more available at all time, and it will be blazing fast, and it will be secure by default by enabling Azure Firewall. Azure Front Door's web application firewall capability. So to demonstrate this, I've created a few applications to go in, but I'm going to just go a bit deeper on the front door profile first, because it has a lot of moving parts. So the front door profile itself is the container of all capabilities of a front door solution. So a front door profile can have multiple endpoints, which is what the user will hit first when trying to access. And this endpoint can then have multiple routes. And the routes is then typically what happens after the domain name. So this can be, for example, domain name /blog or domain name /static images, or whatever you want to have on the domain route. And a route is always associated with one specific origin group. And origin group is the capability that does load balancing across different workloads. So the origin group will have one or more origins, and those origins are then pointing to the application backend, which is serving the content for that route. So that can be a website, it can be a function app, for example, if you have an API available. It can be a container solution. It can be a different load balancer, because you can chain this load balancer up as much as you want. And it can also be basically anything that are accessible either towards on a public IP address. With private endpoints, you can also connect to applications more securely inside of a virtual network, which I also will demonstrate in a few seconds. In addition to the specific routing elements, Front Door also has a quite strong rule engine where you can do, for example, URL rewrites or add additional headers, remove data which is coming from the backends. You have a huge set of capabilities there. And you can, of course, bring your own custom domains and certificates. Another nice thing with Front Door is that when you bring a domain, you can also make Front Door the authoritative for certificates. So you don't have to have a custom you don't need to bring your own certificate. You can just use certificate given by Front Door, which simplifies things a lot. So this is a super simple example where we have a endpoint in Front Door, which is pointing to a default route with just a star, sending it to a origin group, and then via private link accessing a website. So I'm going to switch over and share my screen instead. So can you see my screen, Jan Vidar? Good. So this is the Front Door in the portal in Azure. So we can see here that in the Front Door manager, I've configured a bunch of different endpoints, which can then be used to access the site. So for example, here, I've configured a endpoint, which is demonstrating how Front Door is handling latency. So in this case, I've configured a route, which is just a /* which means that this endpoint and this route configuration will just pick up anything that are sent towards the endpoint. And it's going to be sent to a origin group called website latency. On this one, I don't have any rules in addition. So if you look at that latency group, this latency origin group is pointing to a bunch of Azure websites running across the globe. So I have deployed one in Australia, one in India, one in Norway West, one in Sweden, West Europe, and also West US. And all these have been configured with private link. So the web application in the backend don't need to be exposed on the internet. It will just use the private link service in Azure instead, which makes it more or less direct connection from the Front Door service back into the web application. So my plan was now to try to demonstrate how latency works. So if I copy this URL and opens up a new tab, this will be Norway East for me. So if somebody else in the chat could try to access that URL, I can try to copy paste with a clickable link as well. You should then get the web application which is closest to you from your location. So since Ketyan is in India, you should then get the Central India website if clicking. So if you could confirm that in the chat, that would be awesome. And if you can also send just the image, for example, from your screen, that would be really cool. Yeah, perfect. So this means that the POP location from Front Door have identified that the web application hosted in Central India is closer to you than the one in Norway, which for a human is quite logic, but not necessarily for network traffic, right? So we can see this happening using the Front Door health probing log. So you can see this log has listed a bunch of requests from different locations. And somebody's Belgium, yeah, you got West Europe, great. So that it just works, right? And it's so great. So in this service, I've then configured basically the same application with just a container image and some parameters which will then give you the right location when clicked. So that works. Another thing that I can then demonstrate on that one, if we click in on the origin group again. On the origin group for latency, I've also configured the latency sensitivity to 0 millisecond. That means that it will always choose the closest server for you. In another example where I've configured round robin instead, it will also use latency, but on the origin group, I've also configured a higher level of latency sensitivity. So that means that depending on where you're coming from, you will be routed to one of the two fastest nodes within the latency sensitivity area. So if I try to bring up that URL instead, you can see I'm hitting West Europe because that's within the 200 millisecond window. If I refresh, I should probably get something else. I'm always hitting West Europe for some reason now, but normally you should get the routing. Maybe it's something wrong with my backend. You can try to paste it in the chat as well to see if it works. Should be working. So that's the basics of the routing, right? Another thing which is quite nice to demonstrate is the latency part of this solution. So sorry, the Microsoft backend part of this solution. So if I bring up the front door manager again, I have a website here hosted in Australia, which is really far away from my location. So if I bring that up and paste it in and also bring up the developer console, actually what I'm going to do, I'm going to hit the web app directly first. So if I go back to the resource group and find the MS Backbone application and load that, we should, I'm not sure if it's possible to see this on the screen, but it takes a while until the application is done loading. It actually took almost 4 seconds, almost 4.5 seconds until the application was actually ready to be used by the user. If you're doing that on the backend network for Microsoft instead, I can go back and into the demo again and bring up this one. It should be a bit faster than having to go over the internet. So yeah, so the load is almost the same. So it wasn't that much better this time, but if I refresh, it should probably be even a bit faster. Yeah, I can press it down to 2 seconds. So this depends on a lot of factors, right? So it can go a bit back and up and down, but on the average, it's way faster going over the Microsoft backend and going over internet. And then if we add cache in addition, we can try to load the cached version of this Australia site. The whole loading happened. It was a bit slow the first time. It's probably because the cache has timed out. The cache has been configured to be 1 hour. But if I refresh this, it's down to 30 milliseconds to load the content from Australia instead, because the content has been cached out on the different POP locations from Microsoft instead. So that kind of summarizes a bit how you can use Front Door to speed up the communication a lot with the different services. If you look at, for example, the timing of this, you can see the time it takes to communicate back and forth to the server is way faster, since it's happening with a POP closer to me instead of going all the way to Australia to get the content for the first time. So that kind of summarizes the parts around endpoints, and then you can also configure endpoint to have multiple routes. So in this case, I have an endpoint with both a latency, a priority, and a cache route. And I've also configured this one to have my custom domain as a part of it. So to create a custom domain, you can simply just add a domain and allow it to be using Microsoft certificate. Then you have to add a text record in DNS. And within a few minutes, you will have a valid certificate set to the domain. So if I go to Azure Front Door, afd.anderseide.net, if I'm able to type my name right, and add latency, that endpoint will then point to the closest backend for me in the application. If I'm sending this one into the chat now, and somebody in West Europe clicks it, you will get West Europe instead of Norway East. And if you're doing India, you will have Central India. So on this part, I'm just speeding up parts of a website instead, which is also a quite powerful capability when building more complex applications. Another capability in Front Door is doing priority on the load balancing. So if I go into the priority origin group, in this case, I've configured a set of backends with a priority level. So that means that Front Door will first try to hit number 1, then number 2, and then number 3. So this can be used to, for example, fail over in an application if something goes down. So we can try to simulate that as well. So going back on the Front Door manager, and this might take a few seconds. So I'm going to try to do some kind of voiceover when doing it. But if I'm pasting this one in, I'm getting Norway East now because that is the fastest one. So if I also go back in the resource group where I have the application running and find the server for priority northeast solution and click stop on that server, that will then take the server down and it won't be able to respond to any requests, right? So if I try to click this link now, I should just get an error page saying that the application is not available. And it actually takes a few seconds. So while that fails, I can go back into the Front Door and into the origin group for priority. And you can see I've also configured a different interval on this one. So every 30 seconds, the health probes from Front Door will go and check, is the application up? Is it up? Is it up? Is it up? And if it fails 3 times, it requires 3 healthy requests. Front Door will tag that backend origin as down and start shipping connections over to the Sweden Central web application instead. So this one be loading. There we go. It got an error message. It did at least not load correctly. Yeah, it's down. So back on the priority side, if we wait about 1.5 minutes, we should then have a failover happening to Sweden Central.
So while you're waiting, Anders, there's a question from Ketan in the chat, so maybe you can take that if you are waiting anyway.
Absolutely. Is location-based traffic routing managed through rules that use the client's remote address in Azure Front Door? This happens based on how DNS load balancing happens in the backend. So Front Door will Microsoft backends, when you request a DNS lookup, it will find the POP which is closest to you. So if I do NS lookup on the Front Door endpoint at my site, it will give me a different IP address than you have in India, for example, which will then put you on the POP in India instead of the POP in West Europe. So that's how it finds where you are from and sends you to the closest location. So I probably have to wait a bit more. Let's see if we are able to get it up. It should fail over within a short time. But it's always difficult to wait on things that are down, right? It should be there any second. But this happens based on the interval which is just checking that. So if I can actually show the logs from the health probe, maybe that one can tell us something about what's going on. So if I do like this and click run, yeah, it's getting a lot of errors at least, but it's the pop in my location haven't detected it yet. I can try to share this app as well. That's the website. Sorry about that one. This one. I'll refresh now and send it into the chat. There we go. There's back. So the front door has now detected that the application in Norway was down and has started sending it to the Sweden central location instead. So that demonstrates how priority works with this service. So luckily, it's nothing that will happen way too often, right? Normally sites don't go down, but if you have this configured, they will automatically fail over instead of you having to go fixing something. Do you normally use Azure Front Door as a replacement for application gateway or a combination of both? Yes and no. we actually often see application gateway in the back of Front Door. So a Front Door origin can actually be application gateway. So when application teams build their application, they often like to have full control on the service itself, and also have an additional load balancer or firewall in front of their location. So then they have more control of the solution, and then we publish the application gateway through Front Door in addition. So you can actually then chain it up a bit. So it's if you have a more complex application, which is having a lot of different backend microservices, for example, that one will then normally be deployed in multiple regions with an application gateway in front. And then we publish the application gateway as an origin into the Front Door, which gives you even more paths to success if something goes down. Did that answer your question, Jan?
Yes.
Perfect. So that touches in a bit on the load balancing capabilities. And looking at time, I'm beginning to run short, but I'm just going to quickly show the WAF firewall capabilities as well. So the Front Door WAF is quite similar to the WAF in application gateway. So you can configure it either in prevention or detection mode, and from there you can also go in and use the managed rules from Microsoft and also custom rules if you like. Let's see, new question. Is it possible to configure Azure Front Door to only use certain edge locations? No, it's not. So Front Door, you will just configure the service. The service itself is configured as a global service. It will be just distributed across all the different locations and POPs. What you would do to prevent, for example, somebody from accessing the application from a location that you don't want to have is to add a custom rule and use geolocation on that one, for example. So in that case, you could say that if the geolocation is within a specific region, for example, you will deny the traffic, or you can just deny, or you use is not and select if it's not from Norway, it's going to be denied, for example. So I hope that answered the question, Jan Arve. Would recommend placing the AI Foundry URL behind? Yes, absolutely. So that's actually one of the most common patterns you have with Azure Front Door in combination with AI services. So there you will put the Front Door in front of AI Foundry to secure the AI Foundry endpoints. And I didn't mention that in the beginning, but Front Door supports both HTTP, HTTPS, and WebSockets. WebSockets are currently in preview, but it has support for it. So you can use the Front Door to protect WebSocket workloads as well. which is really good for chat applications, for example. So, and also feel free to unmute if you want to ask questions, if that's something you like. And then based on server availability or latency, yeah. So if you're using a server backend which expects to have the same session coming back every time, you will then of course also configure front door to use session affinity. Is that the name? Let me find it up here. If you go to site latency, oh no, sorry, it's on the route, of course. So going in on the route, you can also configure server affinity somewhere here in the solution. I can't recall the exact place right now, but you can configure it. So it would also then always hit the same server if you have initiated the request, so you can actually find it back again. Good. Any other questions? No. So the web servers will then have the bot protection, for example, and it also has built-in DDoS capabilities in front door. And front door is also the solution Microsoft is using for most of their public-facing services. So it is really a battle-tested service when it comes to security and especially then also DDoS protections. So that concludes the demo I'd planned for today. Is there any question I haven't been able to answer yet, Anne Vidar? Have you seen anything? When I did a private link and recreated using Simrin. Yes. I can't say why it's happening. I've seen it myself as well. The private link connection parts is sometimes acting a bit strange. I'm not sure if it's due to cache or something, but if I delete a private link on the origin, for example, I also have to go back and delete it from the front door and then often wait quite a while before trying to reinitiate it. Then it normally works again. But yeah, it's not a perfect service like anything else. It has its quirks, but luckily the product group is really good at responding to requests, and the support team is also quite good on front door. So if you have strange things like that, it's often easy to get help to have it fixed. Good. I think that concludes my demo for the lunch. Yeah, you got it back after 2 minutes. Yeah, it's quite similar. Good. Lars.
I think in regards to questions, you are top of everything that's have arrived, with the exception of the recent question now from Jan Olav. So you are good with all the questions that have popped in.
Yeah, the OWASP top 10 is part of the built-in protection policies in WAF. And you can also add your custom as well, of course. Good. I have a couple of more minutes, so if you like, I can also stop the recording, which is often a trick to make people want to talk more.
Yeah, just a little note. I saw that the ability to raise your hand is disabled in this meeting. So if you want to ask a questions, just unmute if you want and just start talking. We are not too many people here, or you can type in the chat, I want to ask a question, or you can type it anyway. So yeah, we have some options still. But I see that the raised hand, at least for me, is disabled, and I think that will be applied to everyone.
Yeah, I've seen a couple of raised hands. Martin, yes? Good. I'll click stop recording then, so we can have a unrecorded talk.